In this video, we will talk about some of the configuration in projective geometry. First is plane of plane. In finite geometry, the plane of plane, after Gino Peano was an Italian mathematician known as the founder of finite geometry. Plane of plane is the finite projective plane of order 2. It is the finite projective plane with the smallest possible number of points and lines, 7 points and 7 lines with 3 points on every line and 3 lines through every point. Based on the definition, plane of plane has 7 lines and 7 points. As a VS Math, we all know the points and the lines during the figure. Here's the figure of plane of plane. Then let's talk about the axiom of plane of plane. First is there exists at least one line. As we can see, there have a line in the figure. Second, every line has exactly 3 points on it. For example, in the figure, the line orange in the figure, we see the 3 points attached on it. Also in the blue line, in the red line, and so on and so forth. 3. Not all points are on the same line. It means this figure is non-collinear. 4. For two distinct points, there exists exactly one line on both of them. It means in every line there exists 2 points. Like in the orange line, there have 2 points at the end of it of each of each line. And lastly, number 5, each 2 lines have at least 1 point on both of them. For example, as we can see in the figure, line orange and blue, there is a point connected to it. That's the axiom 5 says. Next one is Hess configuration. Hess configuration in geometry. The Hess configuration, introduced by Colin Maclaurin and studied by Hess on 1844, is a configuration of 9 points and 12 lines with 3 points per line and 4 lines through each point. Based on the definition, it has 9 points and 12 lines with 3 points per line and 4 lines through each point. Based on the figure, it's easily to understand on what the definition says. And lastly, Pappus configuration. Named after Pappus of Alexandria. In geometry, the Pappus configuration is a configuration of 9 points and 9 lines in the Euclidean plane, with 3 points per line and 3 lines through each point. As we can see at the figure, based on the definition, it has 9 points and 9 lines. 9 points like point ABC, XYZ, and A prime, B prime, C prime. Then, and 9 lines like line AC, AC prime, AB prime, and so on and so forth. And last, it has 3 points in every line. As we can see, in the line AC, there exists 1 point like point B in its middle. That is the definition says. And that's the sum of configuration that we talk about. Thanks for listening.